A very good morning to everyone. So, welcome to lecture number 10 on the topic of relative motion. So, yesterday we have started with the constant velocity in we have finished one dimension and we entered into two dimension. Correct? We just started. Okay. So, today we'll see how to solve problems in two dimensions. Okay. Yesterday we finished how to solve the same constant velocity like Riverman problems in one dimension. Of course, we didn't solve any problem. Today we'll take up one or two problems and then we'll go for two dimension problems. Okay. So let's begin. Yeah, this one yesterday we had started this one Riverman problems in one dimension and two dimension, upstream and downstream. Okay, we have seen what is meant by upstream and what is meant by downstream, and then afterwards we have two dimension. Correct? And whether it is one dimension or two dimension, there are three important terms which we have to understand. Okay, one is called as velocity of the river with respect to ground, velocity of man with respect to river, and velocity of man with respect to ground. So first term is called as river velocity, which they'll mention in the problem as the what you call river is flowing with some velocity. That means it is always with respect to ground. And then next part they'll give it as the speed of the man swimming in the river is this much, 5 meters per second. It means that it is with respect to river. It is with respect to river. And in some problems, it can also be given as man's efforts. Instead of telling that the speed of the man who is swimming is 5 meters per second, they'll say it as man's effort is 5 meters per second. Or speed of man in still water is 5 meters per second, they'll say. But all these three have the same meaning, that is velocity of man with respect to river. And then they'll ask us to find out what is the velocity of man with respect to ground. When you stand on the ground, what is the velocity of man? Which is equal to the sum of these two velocities. Velocity of man with respect to river plus velocity of river with respect to ground. Okay. And yesterday I derived it how we got this expression. You have to by heart this expression. Okay. From this only, this is our original basic definition of relative velocity, and from there we got a general equation of velocity of A with respect to ground is equal to velocity of A with respect to B plus velocity of B with respect to ground. And from this general equation only, what you called all the three models equations can be written, whether it is river man problem or aeroplane wind problem or rain umbrella problem, whatever it may be, this is the basic fundamental equation. Okay. So yesterday we have seen downstream and then upstream, correct? And then afterwards we have seen, sorry, this is rain umbrella problems. Okay. You can now see here. Yeah, yesterday we have seen crossing the river also. I just explained it. Okay. So today we'll take up some problems on what we call upstream and downstream, and then we'll go to the two dimensions. Okay. So now let us write one note in one dimension. Okay. So now when you are going in the downstream, okay, when you are going in the downstream, okay, suppose you have started from here, okay. Suppose let's say this is the river. Now generally they'll give this river velocity, correct? Okay. So from now onwards we'll consider it as like this. Okay. River velocity, we'll take it as river velocity is actually velocity of river with respect to ground. Okay. But in general they'll take it as U. Okay. From now onwards, U means velocity of river with respect to ground. Okay. So this is some 5 or something, whatever it may be. Okay. Next, suppose if a man is what you call swimming in this direction, okay, that is called as downstream. Okay. So man's velocity or man's efforts, man's velocity or man's effort or man's velocity in still water. Actually, it is what the velocity of man with respect to river. From now onwards, we'll write it as V. Okay, in general V. Okay? But it is actually, it means velocity of man with respect to river. Now they'll ask us to find out what is the man's velocity with respect to ground. Okay? Man's velocity with respect to ground. Man's velocity with respect to ground is equal to how much? Okay? We know what is the fundamental equation. Velocity of man with respect to ground is equal to velocity of man with respect to river plus velocity of river with respect to ground. Okay, so that is equal to velocity of man with respect to river is what? Now, first of all, this river is moving which side? Right side. So if you assume this as x-axis, positive x-axis, then it is called as u I cap, and because it is a vector quantity. Okay, and then this is also v I cap. So that is equal to u plus v times of I cap. Okay, this is called as velocity of man with respect to ground. Okay. Suppose if the man swims some distance d, suppose let's say from here to here he has traveled a distance d. Okay. Now what is the time taken? Okay, what is the time taken for the man to travel that one? So time taken is equal to, okay, in this topic we have only one equation, please remember. Okay, here all these velocities
S
are
is
constant.
equal to U plus AP, sir.
So S is equal to U times of T. Okay, so only one equation we have. So now I know the distance traveled is what? Actually displacement only, because it is one dimension, we don't have to write anything because it is d I cap only. So d into I cap is equal to this velocity is with respect to ground. This velocity is with respect to ground, which is equal to U plus V times of T. So therefore, time taken in the downstream is equal to distance traveled by U plus V. Okay, so please remember this. Now, in the same, what do you call it? Same thing we'll discuss for upstream now. Same thing we'll discuss for now upstream. Okay. So upstream means only difference come in the velocity of the man. Correct? Everything is same. Now only thing is what? The man is moving opposite to the direction of currents. Current means river currents or river flow. Okay. So river is flowing right side, but man is swimming opposite. River is flowing right side. Okay. And the man is swimming in the opposite direction like this. So now what, suppose let's say here also he has traveled a distance d, let us say. Okay, he has traveled a distance d, let us say. Okay. Now what is the, first of all, what is the velocity of man with respect to ground? Is equal to velocity of man with respect to river plus velocity of river with respect to ground. So that is equal. Velocity of river with respect to ground is what? Right side only. So that is u times of I cap. Now velocity of man with respect to river is what? Left side. So minus v I cap. Okay. So this implies that is equal to u minus v times of I cap. Correct? U minus v times of I cap. Okay. Now what is the time taken? Here also we'll use the same equation. Okay, S is equal to U times of D. Okay. So D is equal to, this is the velocity of man with respect to ground. Please remember, this is the velocity of man with respect to ground. Because time can be calculated from ground frame or from A frame or B frame or river frame or any frame. But generally we calculate here with respect to ground, because this distance is with respect to ground. Okay. So now this is equal to U minus V times of time. So therefore, time in upstream, TU, this is time in downstream, is equal to D by U minus V. And what is meant by U? Please remember, what is meant by U? River flow. And what is meant by V? The velocity of man with respect to river, or his effort also. Okay. So please note down this. Please note down.
Sir, just a small doubt, sir.
Yeah.
Sir, you told that in the middle of the expression, the sign will not change, no sir. But at the last, the sign got changed, no sir. U minus v whole I cap.
Yeah. This is a man is swimming the opposite to the river
Ah,
current.
yes,
Na?
that I understood, sir. But in middle, you said sign should not be changed, no sir.
In the middle, I told sign should not be changed. Huh?
Yes, sir. In expression, sir. You told
Today's
me
class.
yesterday. Not
Sir,
today's class. Yesterday you told
sir,
me.
yesterday you when the expression was explained, sir, there was a doubt that for upstream there's a different formula. That is
Sir,
he's talking
sir,
about.
actually, sir,
Ah, yes,
in this,
sir.
sir, there are two cases, sir. If the man is flowing with greater velocity than river in upstream, and the man is flowing with lesser velocity than upstream, sir. So I think we shouldn't change, sir, until last.
Yeah, yeah. Here you should take it as like this only, depending on the
Sir, I
magnitudes.
think we can take the magnitudes, the positive values we should take, sir.
Yeah, here you should
Otherwise,
substitute.
time will go negative, sir, not
Yeah,
positive, sir.
here you should take positive values. Are you understanding? Huh? Okay.
Yes, sir. Understood.
So now, suppose if the man goes, what you called, this is the third point. First point up downstream, upstream. Okay. So now, if the man starts swimming from point A, okay, river flow is always in the right side. Okay? Unless in other way they specified some other left side, we can see it as right side. Okay, we can see it as right side. So now there is a river flow like this. Okay, river is flowing in this direction. Okay, and a man starts from point A. Okay, man starts from point A and swims like this, like this, like this. This is the man. Okay. Swims, let us say, a distance d and reaches a point B. Okay, and then he turns a U-turn and then comes back to point A. Okay, so now what is the total time taken? Is nothing but
So d of 1 by u plus v plus 1 by u minus v.
yeah, total time taken is time taken in the downstream plus time taken in the upstream. Okay, so time taken in the downstream we already seen d by u plus v plus time taken in the upstream is what d by u minus
U
v.
minus V.
So this is called as the total time. Okay. So please note down this formula. Let us take a problem. Finished? Okay.
Yes,
Okay.
sir.
Now let us see. Let us take one simple problem.
Sir,
Yeah,
one
please.
minute, sir.
Let us take one simple problem.
Sir, just can you zoom out, sir?
If a boat goes from A to B and returns back to A in 2 hours. 2 hours. Find the distance between A and B if speed of boat, okay, that means what you call speed of man, or let us take it as river velocity is given as, that means u. Okay, if u is given as 4 kilometers per hour and v, what is meant by v?
So the
Man's speed,
velocity
sir.
of man with respect to river.
Yeah, velocity of man is equal to 16 kilometers per hour. Okay. So very simple problem. What is given here? The above equation total time is equal to what? What are the quantities given? Tell me for us. U is given, V is given. Correct or not? Okay. And what is the
Sir, is D equal to 15 kilometers?
D here?
D, sir, distance, sir.
Yeah, correct. 15 kilometers. You know, see here, very simple problem. Okay. So now total time is given as what? 2 hours. Okay. And velocity of the river is given as 4 kilometer per hour. Okay. 4 kilometer per hour. Since total time is in hours, you can keep it in kilometer per hour also. And velocity of man is given as 16 kilometer per hour. Okay. Now they're asking us to find out what is the distance. Correct? What is the distance? Okay. So now if you use this equation, total time is equal to d by u plus v plus d by u minus v. Okay. Now here you may get a doubt that sorry, u is 4 and v is 16. Okay. So now here you have to be careful. Okay. That you should take the magnitudes. That means net velocity. Okay. So that is equal to total time is 2 hours. Distance d is what here, which is what we have to calculate. So d by u plus v. U plus v is what? 4 plus 16, 20. For addition, it is not a problem. Okay. Then d by, now u minus v, now you may get it out that 4 minus 16. Okay. Don't worry that here you'll get as actually minus 12. But don't take it as minus 12 because the negative sign we already took it. So just take it as 12. Okay. And generally, this velocity of man will always be greater than velocity of the river. Correct or not? Okay. Suppose let us say if the river is flowing with the what you call 20 kilometers per hour and man is moving with the what you called 5 kilometers per hour, can he swim in the upstream? Is it possible?
No,
No,
sir, he'll go
sir.
back, sir.
Yeah. Okay. So therefore, this value will always be there. Will always be greater than this value in the upstream. Okay. So therefore, you just take it as magnitudes only. Okay. That means mod value you can take. If you want, you can take the mod value always. If you have any doubt, you can take the mod value. And then if you solve this equation, you will get as d is equal to how much? 15 kilometers. Okay. Is it clear? So another one simple question I'll give you. A boat takes 30 minutes less time in downstream. In which stream the time will be less, in the upstream or downstream?
Downstream.
Downstream.
Sir.
Yeah. A boat takes 30 minutes less time in downstream compared to upstream. Okay. Find the distance. Find the distance if velocity of the river is okay, u is equal to 13.5 kilometers per hour and velocity of the man or speed of the boat is 31.5 kilometers per hour.
Sir, is D equal to 18 kilometers?
Yeah, how much?
18 kilometers, sir.
No. And you want to do it as a homework? Simple problem. Just you have to take one small equation. That's all. See here. Now river is flowing right side. We should assume it as like this. Okay. Now this is point A. Okay. So now is starting from point A and then going here to point B. This time taken is how much? Tell me. TD. Okay. Now what happened? Now he'll take a U-turn and then he travels and then reaches here. This time taken is what? Upstream. Okay. Now which one will be more? TU or TD?
TU, sir.
TU will be more, sir.
Yeah. So that means now the difference between these two times is given as how much?
Sir,
TU is more. So TU minus TD is given as 30 minutes. That means I wrote it as opposite. That means the time taken in the upstream is 30 minutes more than time taken in the downstream. Okay. Now, what is the expression for time taken in the upstream? D by U minus V mod. Correct? I told you to take it as mod. Minus of D by U plus V, you will always get as positive only. Okay.
Sir, is it 15 kilometers, sir?
Yeah, 15. Okay. Now, since everything is in hours, so convert 30 minutes into hour, that is equal to half an hour. Correct? So now tell me what is this value? What is the, so D is what we have to calculate. By what is U minus V? 31.5 minus 13.5. How much is that?
18, sir.
18. Yeah. Should I write minus 18? Because U is 13.5.
No, sir.
13.5 minus 31.5 is equal to minus 18. Should I write minus? No.
No, sir.
Yeah. Minus D is what we have to know. By U plus V. What is 13.5 plus 31.5?
sir, 45, sir.
Yeah. Is equal to 1. So to solve this equation, you will get D as 15 kilometers. So as far as this model is considered, riverman problem in one dimension, either upstream or downstream, you have only these two equations. That's all. Okay. Time in upstream, time in downstream. That's all. They may change, they may give different models of problems, but this is the only equation we have. Okay. So I hope it's clear. So upstream and downstream. Okay. Okay. So now let's move into our 2 dimension.
Sir, 1 minute, sir. I did not copy, got disconnected.
Yeah.
Done, sir. Thank you.
Yeah. So now let's move into the 2 dimension. Okay. The riverman problem in 2 dimension. Okay. So 2 dimension means what are the topics? Tell me here. In 2 dimension, what is the topic? Concept called as crossing the river. Okay. That's why I showed the animation. Correct? So now in this also we have 2 cases. Crossing the river in shortest time and crossing the river in shortest path. Okay. So just I'll show you once again that animation. It's very good. Yeah. Are you able to see the screen?
Yes, sir.
Yeah. So now now this is a two-dimensional problem. Why it is two-dimension? Tell me. Because river is flowing which side? X direction. Now man is moving which side?
Y direction, sir.
Yeah, y direction. So therefore it is a two-dimensional motion. Okay. So generally in two-dimensional motion, generally they'll ask two things. Number one, first one is called as drift. Actually, first one is called as time taken to cross the river. Second one is called as drift. Okay. What is meant by drift? Means it is nothing but the distance along the along the river flow which the boat has traveled, or in simple way you can say it as, now normally see here, suppose right now this boat or man is trying to reach which point?
B, sir.
B. Now can he reach B?
No, sir.
No. Where will he reach? Some point on the other side of the river, some point C, correct? Let us see where he will reach. Let us start. Yeah, so this point he reached. So this distance, okay, from B to C is called as drift. This distance is called as drift, okay, which is the distance along the river flow, okay, which is the distance along the river flow. Please remember, okay. So this is called as the drift, okay. So if you want displacement also, you can. Okay. Can you tell me these arrows, which depending on the color, what is this blue color arrow? What does this blue color arrow represents?
Sir, the flow of the river, sir.
It is the river velocity. And what does the red color arrow represents?
So the man's effort, sir.
It is the velocity of the man with respect to river, or man's effort, or velocity of the man in still water. Okay. And what does this black arrow represents? Velocity of the man with respect to ground. Okay. And generally this velocity is used to find out the time. Okay. Generally, whenever they ask time, okay, we have to use this velocity. Okay. Or otherwise there is one more method also, I'll tell you. Okay. So anyway, in this model, you'll be asked to find out two things. One is time, next one is drift. These are basic questions. And then afterwards we have what is the what you call how to cross the river in shortest time and how to cross the river in shortest paths. That is the next one. Okay, so first you have to understand how to calculate these two things. Okay. So now let's begin. So I hope you understood what is meant by drift and all. Okay, so now let us see. Anyway, we'll write down one point as a what you call note as a drift. Okay. Yeah. And write down. Now we have entered into two dimension. Riverman problems or riverboat problems in two dimension. Okay. So let us see drift. Okay. So make sure that this is very important to understand. This drift is nothing but now river is flowing which side? Right side. Okay. Which we call it as U. Okay. Now suppose you have started at point A, okay, and you want to reach exactly opposite points. You want to reach exactly opposite points. This is called as B points. Okay. But now you won't reach B. You will reach somewhere around C. Okay. So this thing is called as, okay, you will reach C. Okay. So this distance is called as what? Drift. This distance is called as drift. Are you able to understand? Or sometimes what happens is, suppose let us say, suppose for example, okay, suppose let us say you are starting here, and maybe you are aiming at here. You want to reach at here. Okay, suppose you want to reach at here. Can you reach B when there is a river velocity? You want to reach B, but will you reach B actually?
No, sir.
Yeah,
No, sir.
you will reach somewhere around some point here, C. So this distance is called as drift. This distance is called as drift. Okay? So please understand this one. Okay? So now let us take some problems, interesting problems. So first we'll start with the basic, okay, kinematics. Okay, let us take one example. Okay, now suppose the question is, these are standard questions. Find time taken to cross the river. Time taken to cross the river. Second one, displacement along the length of the river. Displacement along length of the river, which means what does it is? What is this term called as? What is this term
Drift,
called
sir.
as?
Drift,
Yeah,
sir.
drift. Basically, they are asking drift. Okay, and then the given quantities are like this. Okay, where there is a river like this. The width of the river is given as, okay, the width of the river is given as 100 meters. Okay, the width of the river is given as 100 meters. Okay, and so that means now what you call river is flowing like this. Yeah, now river is flowing with the velocity of what we call. First, we'll start with the next problem. We'll take river velocity. First, assume that in this problem, only because since it is a starting problem, okay, we'll take it as since it is a starting problem, we'll take it as that the river is not flowing. River is not flowing, and then slowly in the next problem we'll include velocity of river also. Okay, since it is the first problem, we'll start with this one, so that is very easy to solve. Okay? River is not flowing. Please remember here. There is river, stand still. Okay, that means still it's not flowing. Okay. Now there is a man. Okay, here let us say some point A. Okay. Now he is what you call moving with some velocity v like this. Okay. Okay. Now since river is not flowing, whichever direction he reaches, that is the what you call he will go to that point only. No? Suppose let us say if he is headed in this direction, then he will reach exactly here. If he is headed in this direction, he will reach exactly here because river is not flowing. Correct or not? Suppose if he is going like this, then you can easily tell what is the time taken means. Now suppose let's say his velocity is given. Velocity of man is given as 10 meters per second. Okay. Now it's very easy to calculate. Correct or not? Because why in this direction his velocity is 10, distance we know, and only equation we have is what s equal to ut. So that is 100 is equal to 10 into t. So which implies 10 seconds. Correct or not? So if he travels in this direction, okay. But suppose, okay, let us say if he is not traveling in this direction, he is traveling maybe at an angle like this, at an angle of 37 degrees, maybe at an angle of 37. Now, where he will reach some point here, correct or not? He will reach some point here. Okay. So he will reach here exactly, correct? Because river is not flowing. Okay. Now, now they're asking what is the time taken and what is the displacement along the length of the river. Here, displacement along the length of the river means in the sense that
0, sir.
displacement. First, listen. Displacement along the length of the river here means it means that he is traveling from point A, and what is the opposite point exactly here? Opposite point is what here?
B, sir.
Yeah, this is the B. Okay. So now he is reaching point C. Okay. So now when he is traveling, they are asking basically this distance, the displacement along the length of the river, which is basically this one. Are you able to understand them? Okay. So now what you have to do is, okay, you just resolve in what you call whenever two-dimensional problem is given. Whenever two-dimensional problem is given, what we'll do? We'll resolve in two directions. That's all.
In
Now take
components, sir.
yeah, components. Take this as x-axis and this as what? Y-axis. This is x-axis. This is y-axis. Take the starting point as the origin always. Okay, and this is x-axis and this is y-axis. Now, what is the now? Now let us see. Now, this point is clear, na? This point is when he is traveling exactly what you call perpendicular to the river flow. Okay. Now he is not traveling perpendicular to the river flow. He is traveling at some angle. Okay. So now, when you are asked to find out time, okay, whenever you are asked to find out time, what you have to do is better to solve in y direction, just like in projectiles also. Okay, just like in projectiles. Okay. So first of all, let us resolve in x direction and y direction. Let us resolve in x direction and y direction. In this problem, I don't have to resolve because it is just exactly in one direction only. Okay. So now let us resolve in x direction and y direction. Okay. Now in x direction, what is the velocity of the man? What is the velocity of the man in x direction?
10 cos 37, sir.
Yeah, this is the component, correct? Which is equal to 10 cos 37, correct? In x direction. And what is the velocity of man in y direction? 10 sin 37. 10 sin 37. You have to understand, no? This is called as 10 sin 37. This is called as 10 cos 37. Okay. Now, now I need to calculate what you call time and distance, correct or not? Okay, time and distance. So now see here, you can calculate time in x direction or y direction, doesn't matter, but generally we calculate in y direction. Why? Because I know definitely, see here, very important point. Yeah, please listen here carefully. Now your starting point according to coordinate geometry, what are the coordinates of the starting point? Tell me. 0, 0. What are the coordinates of the ending point? X, how much it has traveled? Suppose let us say it has traveled some distance x. Okay, this distance it has traveled.
Sir, x comma 100.
Yeah, x comma 100. Okay. So now that means the displacement traveled in x direction is x, and the displacement traveled in y direction is how much? How much?
100, sir.
Yeah, 100. And I'm taking this side as positive, so both are positive. Okay. So now what you call? Now you have two quantities, and now we have to calculate time. Now tell me, in which direction is easy to calculate time?
Y direction.
Y direction.
Because I know two quantities, na, and there is only one equation, S is equal to UT. In the upstream and downstream previous case, there is only one dimension, so you don't have to. There is only one equation. You don't have to write x in x direction or y direction. But here it is in y direction. Y direction. Same way here also, S is equal to UT. X direction. X direction. That's all. And time is same whether you calculate in x direction and y direction, but here you cannot calculate time because this is also unknown. Two unknowns you cannot calculate. But here two known quantities we have, so it's very easy to calculate. Now tell me, what is the displacement in y direction? 100.
100, sir.
What is the velocity in y direction? 10 sin 37. 10 into 3 by 5. 10 into 3 by 5, that is equal to 6. So therefore 6 into 3. So time taken is equal to what? 100 by 6 seconds. Once you get time, just like in projectiles, we calculate range. Na? Okay. So same way here also, x is equal to, what is here? 10 cos 37. That is equal to 10 into 4 by 5. So 8. So 8 meters per second into, what is the time? 100 by 6 meters. So that means it has traveled, what we called 8 into 100 by 6 meters. Okay, is it clear? So here what I'm telling is not the answer, how to get the answer. I'm telling the concept or the basic methodology of how to analyze a problem in 2 dimensions. Are you understanding? Catch that point. Catch that point. Okay. Now, once you know this method, then it's what you call, you can apply to any, what you call, any problem. It is the same method. You have to understand. Okay. So now let us take the second problem where river is flowing. Once you understand this method, now it's very easy. Okay. Now let us take a second problem where now river is flowing. Where river is flowing. Okay. So suppose let us say this is a river. This is the river. Width of the river is given as same 100 meters. Okay. Width of the river is 100 meters. Okay. Now river is flowing. Now let us take that river is flowing. Okay. And the velocity of the river is given as u. U is given as 3 meters per second. Okay. And a man is, what do you call it? Just 1 minute. I'll write it here. Now river is flowing with 3 meters per second. Okay. And the man's speed is given as 4 meters per second. Okay. And he is trying to swim in perpendicular direction. Trying to swim perpendicular to river flow. Perpendicular to river flow. That means his effort is which side? Tell me. His effort is which side? His effort. Suppose he is starting from here, point 2. Now his effort is which side? Trying to swim perpendicular to river flow means he is trying to move which side? Tell me. He is trying to move which side? Perpendicular to the river flow, like this. So that means he what you call, his aim is to reach this side, correct or not? But will he reach here?
No,
No.
sir.
Will he reach point B?
No, sir.
Where will he reach? Somewhere?
He will reach somewhere around C, sir.
Yeah.
Direction tan inverse 4.
Yeah. Okay. So now first question they are asking. Okay, the first question which they are asking is, what is the speed and direction with which what is the speed and direction with which man moves with respect to ground? That means which quantity they are asking? Tell me. They are asking which quantity? Velocity of what? Velocity of what? Man?
Man, sir, with respect to ground.
Yeah, velocity of man with respect to ground. Are you able to understand or not? Okay. Velocity of man with respect to ground.
Sir, is it 5 meter per second?
Yeah, yeah.
Sir, and
So
the
now-
direction is 53 degrees, sir.
Yeah,
Towards right.
yeah. See here. So now, okay, so this is the first part of the question. Okay, so once you calculate that one, that is very easy because already I told you, correct or not? And then next question is what? As usual. What is this one? In the previous one we have calculated. What is that one? Time to cross the river. Time to cross the river. And then third one. Okay. What is the third one? Tell me. The third one is called as drift. Third one is called as drift. Okay. So generally these things will be asked. Okay. And to calculate what you call, this is basic thing. Okay. Yesterday we discussed how to do this one and all. Okay. So now let us see. Okay. So first one, let us see how to calculate the first one. What is the speed and direction with which man moves with respect to ground? What was the equation? Tell me. What was the equation we have? Velocity of man with respect to ground is equal to velocity of man with respect to river plus velocity of river with respect to ground. Now, given velocity, see here, given what are the given velocities? This only, correct or not? Now, tell me, what is the velocity of river with respect to ground? 3
3,
meters. Which
sir.
side? Which side? Which side is this? 3 meters per second.
Sir, towards right, sir.
So this is a 3 I cap. This is 3I cap. Now, what is the velocity of man with respect to river? He's trying to swim which side? Trying to swim
4J
which
cap,
side?
sir.
Yeah, 4J cap. Okay, he is always trying to swim this side. See here, please once again listen here carefully. He is always trying to what you called moving this side only. But because of river, he is pushed. See here, you can see the direction of the boat. I'll play. See the direction of boat. Boat is always which side? Tell me. J or not?
Yes, sir.
Yes, sir.
Has the boat direction changed? No. His effort is always trying to move this side only. Are you able to understand? Okay. His effort is always towards B only. But because of river flow, he's going to some other point C. Okay. Just like in your studies also, your effort is always to get good marks only. Okay. But somehow you end at some other point. Correct or not? Your effort is always towards 100 marks. Correct? But somewhere you will land like that. Okay. So his effort is always that side. So therefore, we will always write velocity of man with respect to river is 4J cap. Okay. Is it clear? So that means now what is the magnitude of this one? Tell me how to calculate the magnitude of this one.
So root over 4 square plus 3 square, sir.
Velocity of man with respect to ground magnitude is equal to root over 4 square plus 3 square. So that is 5 meters per second. Okay. And then we can always draw, as I told you yesterday, the triangle. What is the triangle? Tell me. What is the triangle? Okay. Even here also, I showed you this triangle. Okay. See the triangle. What is this triangle? Tell me. Velocity of river with respect to ground. This is velocity of man with respect to river. This is velocity of man with respect to ground. So always remember this triangle. This triangle is very, very important. This triangle is very, very important. This triangle is very, very important. This is called as velocity of river with respect to ground. Or we can also say it as U. We can also say it as U. And then now according to that, what do you call, this is another, yeah, another color I'll use. This is called as velocity of man with respect to river. And then resultant velocity is called as velocity of ground. Velocity of man with respect to ground. See here, from this diagram only I got this one. Able to understand that? Okay. This, okay. In that animation, it is shown as this one, like this. In that animation, they have shown it as like this. Both are same, correct or not? The animation you are shown like this, correct? Okay. This is same as this one. Either you can remember that way or this way also. Both are same. So now this is the magnitude of 5 meters per second. This is called velocity of man with respect to river is 4. This is how much? Which is equal to 3. So now you got it right angle triangle, correct? Now what is the angle here? Tell me. Theta is equal to 4 by 3. That means 43. So tan theta is equal to 4 by 3. So which implies theta is, sorry, 53 degrees. Okay. So that means finally he will move at an angle of 53 degrees with river flow. With river flow. With the river flow. Are you able to understand that? Okay. Now, is it clear? Now let us calculate second one. Time taken to cross the river. Time taken to cross the river. Okay, is it clear? Time taken to cross the river. Now, how can you do it? This one.
Solve in y direction, sir.
Yeah.
So 2 components.
Yeah.
Sir, is it
solve it.
25 seconds?
Yeah. So now please listen here carefully. That now second problem solution is let us resolve in x direction and y direction. Okay. Now see here. Now in the first case, see here. First case where I took the river is not flowing. So river is not flowing, only man velocity is moving. So therefore directly we don't have any problem. Directly only one velocity is there. So therefore we wrote that x component, y component. And if it is traveling only in one direction, then there is no problem. Directly this one we got it. But suppose if it moves, if the man moves at some angle, we can resolve. There is only one velocity. Okay. Now here we have three velocities. Are you understanding? Here we have three velocities. So now which velocity is what we need to resolve is this velocity. And that is the reason why I asked you to calculate this quantity first. Okay. To calculate this one, okay, first you have to calculate this one. Okay. So now you resolve velocity of man with respect to ground in x direction and velocity of man with respect to river in y direction. Are you able to understand? Okay. Velocity of man with respect to river in x direction. Now, now listen here carefully. That now this red vector is there, na? That is the vector which I have given. Are you able to understand? Okay, that is the vector which I have, which you have to take. Suppose let us say this is the river. Now this is the river. Okay. Now this is the what do you call the vector quantity. Now this is the velocity of man with respect to ground moving with 5 meters per second at an angle of 53. Now previously how did we calculate? Tell me. Same thing we have discussed. Na? Here you see. Here also I gave 10 meters per second at an angle 37. How did we do? We resolved and then we applied. Correct or not? Is it clear? So same thing now you resolve. Of course, here one more method is also there. Tomorrow I'll tell. That is just by diagram. Okay. You can solve it in some other ways also. Okay. So now you see, now this can, now let me take this as the origin. Okay. Here also river is flowing. See, this is the net velocity. Now finally, as the river is flowing, finally he is moving in this direction. Now we are taking that one into consideration. Are you able to understand or not? Okay. So this is the river. Okay, river is flowing, but now finally we calculated, na? Taking account into this river flow and man's effort, finally he is moving in this direction. So now let us resolve. Now let us resolve this into two components. Okay, first let us take this as the x direction and this as the y direction. This is called as x direction and this is called as y direction. Okay. And this is called as what we call the origin 0, 0, and then finally he will move here. Okay, so let us say this point is B, this point is C. What are the coordinates of C? X, 100.
100, sir.
Now tell me what are the components of this one? Tell me 5.
5 cos 53.
And this is 5 sin.
5 sin 53.
Cos 53. How much is cos 53 in this triangle only is there? Adjacent by hypotenuse. That means how much?
3, sir.
3. This is
4.
Now what is the displacement in x direction and what is the displacement in y direction? This you have to get it from coordinates. How much it has moved in x direction? X. How much it has moved in y direction? 100. Now time you have to calculate. S is equal to u. Okay. This is equal to y direction, y direction. So that is equal to how much here? 100 is equal to 4 times of. So t is equal to how much? 25 seconds. Correct?
Yes, sir.
And once you get time t, then s is equal to u. X direction, x direction. S is equal to ux is this one is 3 into time is 25. So that is equal to how much? 75. Are you able to understand? Is it clear?
Yes, sir.
Yeah. So this is the standard method I am telling you. This is the standard method for solving any problem. Okay. So generally they'll ask two quantities. What are the two quantities? Tell me. Time taken to cross the river and drift. Okay. Now to calculate time taken to cross the river, first step is you have to calculate this one. In this problem I have given. From next problem onwards, directly they'll ask us to find out what is the time taken to cross the river and what is the drift. Shall I give one problem?
Yes, sir.
Yeah. Easy or difficult?
Sir,
Easy
this
only, sir.
before someone's zoom out, sir. Full.
Before some, this one. Huh?
This one. Yes, sir. Yes, sir. Overs.
Yeah. Next one. A person tries to swim across a river. Now, in the first problem, river was not flowing. That was the problem. No? First, we have taken one first problem where river is not flowing, and if the man moves exactly what you call perpendicular direction, this is the answer 10 seconds. And if the man moves at some angle, we have calculated, resolve in two directions and then calculate. And next problem, we have included what the speed of velocity, what you call velocity of the river. Okay, and now in this case, river is flowing and man is trying to swim perpendicular to river flow. Now, same case, river is flowing. Now, man is not trying to swim perpendicular to the river flow, but at some angle. That's all. A person tries to swim across a river at an angle of 37 degrees with the direction of river flow. With the direction of river flow. With the direction of river flow. Okay. With 10 meters per second. And given u is equal to 5 meters per second. That means this is what, tell me?
Sir, V, sir.
Yeah, this is u already. Okay. So now find time to cross the river and drift. That's all. Okay. Can you do it? Very easy, no? Diagram I'll give you. You can do it up. Okay. So tomorrow onwards we have offline. No? Correct? Eh?
Yes,
So
sir.
what is the distance between the two banks, sir, river banks?
Yeah, I'm giving 100 meters. Here, this distance is given as 100 meters. This distance is given as what? 100 meters. Okay. Now, here river is flowing or not? Is river flowing?
Yes, sir.
Yeah. Now, man is trying to know river velocity is given. Okay. Now, let us say man starts from A. Now, in which direction he is trying to swim? Given in the problem. At an
Yes,
angle
sir,
of?
with river flow, sir.
Yeah. Is he trying to
37
swim in this direction?
No, sir.
He is
No,
trying to
sir.
Right,
swim.
sir.
Yeah.
At an angle of 37.
Yeah. At an angle of 37 degrees. And this is, remember, velocity of man with respect to river only. Okay. Now will he reach exactly this point?
No, sir. Still with
will
a smaller
Yeah.
angle, sir.
He will reach at some other points. You have to understand that? Okay.
Yes,
So,
sir.
yeah. So now we can calculate. So first step is what? Calculate.
Velocity of man with respect to ground and velocity of river with respect to ground.
Yeah. First you calculate this value. Okay. Second, resolve in x direction and y direction. Resolve this quantity in x direction and y direction.
Sir, is
Simple.
the
Sir, is the
time
answer is 100
109?
by 6 seconds, sir?
Which one? Time? Huh?
Yes, sir.
Sir, 100
Yeah.
by 9, sir.
100 by 6.
100 by 6, sir.
Yeah, correct. 100 by
Sir,
6.
and the drift is 1300 by 6, sir. 1300 by 6 meters.
Yeah, 13 into 100 by 6. That's it.
Okay, sir.
Okay. Once
Sir,
you
can you
get,
show the question, sir?
yeah. Have you understood the method solution? Okay. Here I did not ask here find the velocity of man with respect to ground, but you have to calculate this to calculate time across the river. Are you able to understand that? Okay. So this is called as a standard method. This is called as what? What is this? Tell me. What is this method?
Standard method.
Yeah. But there is one more method which is very easy method, which is called as a diagram method. Which is called as what? Tell me. Which is called as diagram method. Okay. From the diagram you can solve this problem. Okay. I just tell that one because from tomorrow onwards anyway this online we don't have it. So I'll tell that one. Okay. So now according to the diagram, standard method is this one. This one I already told you. This is called as method 1. Standard method. This you can apply for any problem. Even diagram also, but you have to be careful with diagram. Okay. This you know how to calculate velocity of man with respect to ground, no? Velocity of man with respect to river plus velocity of river with respect to ground. Now velocity of river with respect to ground is easy because I cap only. But what is the velocity of man with respect to river? You have to resolve into components. Are you understanding that? Okay. So now next method 2 is called as diagram method. Okay, which we are writing in equations, we'll put it in diagram. That's all. Okay, is it clear? Which we are writing in equations, we'll put it in diagram. Okay, see here, very easy one. Now they have given what you call velocity of man with respect to river. Correct? And first of all, river is flowing or not? Tell me. With what velocity river is flowing? Tell me.
Yes, sir. 5 meter per
5.
second, sir.
Yeah. So velocity of river is 5 meters per second. Okay. So keep it like this. Okay. Now, just for understanding, I'm drawing like this. Otherwise, in one diagram only we can represent that. Now, as this river is flowing, okay. Now, suppose let us say, okay. Now this is the man. Okay. Now man is trying to swim at what direction? Tell me. This is the velocity of man with respect to river. Yeah. What is this angle? Tell me. 37. How much is this value? 10. Correct? Yeah. Are you able to understand that? Okay. Now, if there is no river, he will move directly like this only. Correct or not? Are you able to understand? Okay. But now here river is also flowing, correct or not? River is also flowing. There is a river. Okay. Now see here. Now this river is flowing. Now if I resolve this component, if I resolve this velocity of man with respect to river in this direction, how much is this component? Tell me. In this direction, what is this component? 10 cos 37. This component is what? 10 sin 37. 10 cos 37 means how much? Tell me.
8,
Cos
sir.
8. So that means this is 8. This is equal to 6. Yeah. Now see here. This is what you call velocity of man with respect to river. That means when river is at rest, the man is moving like this. Correct or not? But now actually when you combine these two, this is called as velocity of river with respect to ground. Correct or not? But finally when he is traveling in the, or when he is swimming in the river, okay. Now see here, when he is swimming in the river, now in x direction, his effort is how much?
Sir, 8
Effort.
plus 5, sir.
His effort is how much? Tell me. His effort in this direction is how much?
8, sir. 8 meter per
8, sir.
Yeah. But in that direction, river is also flowing with what
5 meter per
velocity?
second. So total 30 meter per second, sir.
Yeah, that is what you have to get it. Okay. So that means now in this direction, the man has a net velocity of how much? 13 meters per second. In this direction, he will go with the same velocity only, no? Constant velocity, 6. Nobody is pushing, correct or not? Okay. So 6. Are you able to understand? So this is called as the velocity of man with respect to ground basically. In diagram I have drawn. This is called as velocity of man with respect to river. This is called as velocity of river with respect to ground. You able to understand or not? Okay. Is it clear? Okay. So now if you complete this parallelogram. Okay. If you complete this parallelogram, then you will get as now tell me what is this quantity called as?
Velocity of man with respect to ground, sir.
Yeah, this is the velocity of man with respect to ground. Yes. Okay. Now you don't have to write anything. Now see here, this distance is how much?
100, sir.
100.
So time equal
time-
100 by 6, sir.
Yeah, you got it directly. Correct or not? Now this distance is what we have to calculate. X is equal to what velocity?
13, sir. 13 into 100 by 6, sir.
Yeah. Correct. Which one is easy?
Diagram method only easy, sir.
Yeah, diagram method is easy, but you have to understand it properly. Okay, are you able to understand that? This is called as actually you don't have to draw this many diagrams, one diagram, but for clarity and for your understanding purpose, I have drawn like this. So here velocity is, river is flowing like this. Now man is flowing. Now resolve this velocity in the river flow direction and perpendicular to river flow. Now this is his effort only, na? Velocity of man with respect to means his own effort. But in this direction, river is also helping. So that means net velocity is what? This one. So basically this equation only we are representing in the diagram. Velocity of man with respect to river plus velocity of river with respect to ground. Okay. This equation, if you write in what you call x direction and y direction, you will get these values. If you write this equation in x direction and y direction, okay, in x direction, tell me velocity of man with respect to ground in x direction is equal to velocity of man with respect to river in x direction is 8 plus velocity of river in x direction is 5. So 8 plus 5, 30. Velocity of man with respect to ground in y direction is what? Velocity of man with
6,
respect to river in y direction is 6 plus 6 plus velocity of river with respect to ground in y direction is how much? 0, na?
0, sir.
Yeah, that is what we are getting. Both methods are same, but this diagram method will help you what you call to actually visualize and see and to get it very effectively, very easily you'll get. Just you'll resolve this, you'll add this, and then you'll calculate that. Okay. Both methods are easy only. Okay. So those who find it first method, they can solve it by first method. Those who find it second method easy, they can solve it by second method. But method is this one only. Okay. And then once you understand this basic methodology, you can solve any problem. Okay. So that's all for today. For
Sir?
last day.
Sir, can you tell us the syllabus for today's weekend's exam, sir?
This weekend exam.
Yes, sir.
Yesterday I told you, no? Projectiles and relative motion.
Sir, relative motion up to which topic, sir?
Relative motion up to this what you called rain umbrella, this riverman problems. Not aeroplane wind and what you call next one is rain
Rainman.
umbrella. Yeah, excluding aeroplane wind and rain umbrella up to that point. That means up to rain.
Until today, sir.
Yeah. In fact, tomorrow also, I think tomorrow, until tomorrow. Tomorrow is Wednesday, no?
Yes, sir.
Yeah. Tomorrow I'll cover what is the what is the time taken for crossing the river in shortest time and what is the path to cross the river, shortest path to cross the river. Tomorrow I'll discuss this. First I explain the foundation, the concepts. Okay. Then tomorrow we'll see. Now, once you understand this basic method, now even you also you can what you call calculate it. Now tell me what is the shortest time. Time is nothing but the y component of velocity by what you call distance by y component. Correct or not?
Yes,
this
sir.
one only we have to
100%.
calculate. Yeah, this one you will get it as I think v sine theta. So that means d by tomorrow I will explain v sine theta. And when it is minimum, when this numerator is maximum. So when it will be maximum, sine is maximum. When is sine maximum, theta is 90. So that means, that means to cross the river in the shortest time, you have to put your effort in this direction. You have to put your effort in this direction, then you will cross the river in the shortest time. Okay. But this may not be the shortest path because you will travel long distance, no? Correct or not? But the time will be short.
Yes, sir. The drift must be 0, sir, for shortest
Yeah.
path.
Yeah, 1 minute, I'll show you that one also, since this animation tomorrow onwards it will not be there. But for those what you call students whose class has projector, I can show it. But those students who don't have projector, I cannot show it. Okay, but anyway, I'll just show it here once. 1 minute. Okay, shortest time. See here. If you travel in this direction only, shortest time. See the time here. Okay. See the time. Okay. So if I travel like this only, I can cross the river in the shortest time. See the time, how much? Yeah, how much time?
200 seconds, sir.
Yeah, but is it the shortest path? He is traveling black arrow, no? Correct or not?
Yes, sir.
Okay. So black arrow means, suppose let's say this is 100 meters. This is some 50 meters. He has traveled how much? Root over?
100 square plus 50 squares, sir.
So this is not definitely shortest path. Correct or not? When do you say he has traveled shortest path? When this black arrow is exactly A to B.
Perpendicular, sir.
Yeah.
A
So
to
that
B,
means,
sir.
yeah. So that means for the black arrow to be A to B, he has to put his effort in which direction?
Opposite to the river direction, sir.
May not be opposite, but at obtuse angle. Correct? But
Yes,
at some
sir. Yes,
obtuse
sir.
angle. See here, I'll change this angle. Then you can see. See. Correct? Now he is traveling how much? Exactly 100, na? Black.
Yes, sir.
But he has to put his effort in this direction. Correct? Now he is traveling in shortest path. But is this the shortest time?
No,
Let us
sir.
see. Let us see. How much?
228.23 seconds, sir.
Yeah. So to cross the river in shortest time, he has to travel in which he has to put effort in which direction?
In direct straight, sir. A to B, perpendicular.
Yeah, perpendicular to river flow. Then he can cross the river in shortest time. To cross the river in shortest path, he has to travel at an obtuse angle like this. So these things tomorrow we'll see. Okay. So thank you all very much. Have a nice day.
Thank you, sir.
Thank you, sir.
Thank you, sir.